Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you should have x minus 8 times x minus 1. For the math knowledge question, you're just going to plug in the two values they give you. So we're going to have 4 and then negative 1 squared minus 3, negative 1, and 3. So negative 1 squared is just 1, so times 4 is 4. And then minus negative 9, so plus 9, gives you 13. So that would be your answer for your math knowledge question. We are going to look at lesson 25 today, which is dealing with age and rate problems. So hopefully you'll understand how to do these word problems after this lesson. So we're going to start with age problems. 10 years ago, Thomas was twice as old as Patricia. So we're going to let T be Thomas's age now. So 10 years ago, whatever his age now is, you would subtract 10. And so 10 years ago, that age was twice as old as Patricia. And that was her age 10 years ago. So you need to make sure that you put the minus 10 inside of the parentheses. And then it says 5 years from now. So Thomas in 5 years would be T plus 5. He will be 10 years older than Patricia. So that's going to be Patricia's age in 5 years. So 5 years from now, Thomas will be 10 more than Patricia. So I can simplify these a little bit. This top equation can become T minus 10 equals 2p minus 20, which is 10 equals 2p minus 10. And I can substitute that into this bottom equation here. So I'd have 2p minus 10 plus 5 equals p plus 15. And so 2p minus 5 equals p plus 15. If I solve for p, you should get that it equals 20. So Patricia is 20 right now. And if Patricia is 20, 2 times 20 is 40 minus 10. Thomas would be 30. Okay, so that's how you can work through those. You don't have to work it the same way I did, but you should have these two equations the same. Okay, we're going to look at some rate problems now. We have Joe Frank washing a car and Merle washing a car. So the formula that you're going to use for these is the rate of Joe Frank and the time of Joe Frank plus the rate of Merle and the time of Merle are going to equal the job together. So the rate of Joe Frank is 3 cars in 5 hours. We're going to come back to the time. The rate of Merle is 4 cars in 3 hours. And we're going to come back to her time. Or his, I'm not sure if Merle is a boy or a girl. And it says we need to wash 15 cars. So that's the job that we're trying to do. So it says Joe Frank works for 2 hours and then Merle joins in. So Joe Frank's time is 2 plus the time they work together. And then Merle's time is only the time that they work together. And so then you're just going to have to solve for the time that they'll work together to find your answer. So we're going to distribute here. And we'll have 6 over 5 plus 3 over 5t plus 4 over 3t equals 15. So we can combine 3/5 and 4/3. The common denominator would be 15, and that would be 9 and 20. So we would have 6 over 5 plus 29 over 15 equals 15. And then if you subtract 6/5 from 15, you should get 69 over 5. And then from there, I'm going to multiply by the reciprocal. And 29 is prime, and 69 does not divide by 29. But this 5 will divide by 5, and this 15 will divide by 5 to give us 3. So if you do 69 times 3, you'll get 207 over 29. And it's in hours, so that's our units. So 207 over 29 hours. Very often you're going to get weird numbers here, and that's okay. But that's how long they would have to work together to finish washing the cars. Approximately 7.14 hours. But just leave it as a fraction for your answer. Okay, so this is one formula that you may want to write down because you'll be using that for these. And it just depends on the information they give you as to which variable you're going to be solving for. Okay, now we're going to look at Maya and Wilbur emptying bottles. So we're going to use the same formula. RT of Maya plus RT of Wilbur equals the jobs. So Maya's rate was 2 over 3. And then working with Wilbur, she found that they could empty 4 bottles in 3 hours. So that's not Wilbur's rate, that was them together. So the way that you're going to convert this into information you can use in your formula, their job, they completed 4 bottles in 3 hours working together. And so that means that we're going to be able to find the rate of Wilbur, which is what it asked for. What was the rate of Wilbur? So that's how you would set that up. If they give you one rate and not the other rate, then the other information is going to go into the job and the time they work together. So now we're going to multiply. 2/3 times 3 is 2, and plus 3 rate of Wilbur equals 4. So if you subtract the rate of Wilbur, 3 times the rate of Wilbur is 2, and then divide to give you the rate of Wilbur is 2/3. So that would be his rate. Okay? So again, same formula. They gave us different information though. Now we're going to look at a different kind of formula. It says 5 workers can do 1 job in 8 days. How many workers would it take to do 3 jobs in 7 days? So when you have a random problem like this, your formula is RTW equals job. We are assuming that the workers work at an average rate. So we don't know how many workers I know that workers don't necessarily work at the same rate, but we are just assuming that they work at the same rate. Everybody does the same amount of work in the same amount of time. So RTW equals J. This is a formula you're going to want to use when you have workers and they don't tell you specific names of them, or if you have more than 2. So we're always going to be solving for the R. We don't know the rate that the average worker works at. So the time they told us was 8 days, the number of workers was 5, and the job that they were doing was 1 job. So our R is going to be 1 over 40. So now we're going to go back to the same formula that we started with. We know that our R is 1 over 40. It says how many workers, so we're going to be solving for the workers here. And it would take to do 3 jobs in a time of 7 days. So if you multiply, you'll have 7 over 40, W equals 3. And then you can multiply by the reciprocal on both sides. And so your workers would be 120 over 7. So obviously that is a decimal. It's 17.14. But don't round it to 18. It says how many workers. I know that's not, you can't possibly have a decimal fraction of a worker, but that's okay. For workers is 120 over 7. That's what you put for your answer. Okay? So don't worry about the fact that you can't have a fraction of a worker. Just give the fraction answer and move on. Okay, we're going to look at one more. We have 252 gallons of milk, and this would feed 42 infants for 12 days. Then 14 more infants were placed in the nursery and 48 more gallons were provided. How long would the milk last now? So again, this is going to be an RTW equals J problem. So we're not going to know the rate. They're never going to give that to you. We had 252 gallons of milk, and it would feed 42 infants for 12 days. So our time is 12. The number of workers that we have is 42 infants, because they are going to be working to drink the milk. That is the job that infants have. Besides sleeping and pooping, they're supposed to drink milk. So their job is to drink that milk, 252 gallons of it. So if we solve for our R, you would have 504 R equals 252, which if you solve for R would give you 1/2. So that's your R. So now we come back to the same formula and we start over. Our rate is 1/2. It says how long, so we're going to be solving for the T. We don't know the T. We'll come down here. And then the workers, those are the infants. So we started with 42 infants, and then they added another 14 infants to that. So now the number is a total of 56 infants. Okay, and then the job, they had 252 gallons, but then they gave us an extra 48 gallons because we had some extra infants added. So we would have 1/2 T, this is 56, and then 252 plus 48 is going to equal 300. And then you can multiply over here. 1/2 times 56 is going to be 28. And then if you do 300 divided by 28, that gives you 75/7. So our units were days. So that's a little over 7 days. But 75/7 days is how long our milk would last now. Okay, so those are some of the formulas that you'll be using. Your homework tonight, you do get to omit 16 and 26. So make sure that you do the other questions so that we can go over any problems that you have tomorrow.